This is the practice test to the actual test. We're going to do a couple of videos. This first one, obviously on the first part of this practice test. Number 1, 2, it's worth 2 points, graphing that logarithmic function. So there's several steps, that's why it's worth 2 points. The first thing to do is to identify your h and k. Your h is what? -3, and your k is what? -1, which means that you're going to ultimately shift your coordinates 3 units to the left and 1 unit down. That's after you get your coordinates of this boxed-in parent graph. Now, in order to get the coordinates of that boxed-in parent graph, it would be better to begin with the inverse of that log base 1/2 of x. So the inverse of log base 1/2 of x is actually covering up the log, and it'll look like y equals 1/2 to the power of x. That is the inverse of log base 1/2 of x. So let's actually write that down. Y equals 1/2 to the power of x. And let's come up with some coordinates for this inverse of that boxed-in function. Let's use consecutive integer inputs like -3, -2, -1, 0, 1, 2, and 3. And let's plug in the easiest one, which would be 0. And when we plug in 0 right here, 1/2 to the 0, anything to the 0 is 1. And instead of plugging in the other inputs, since they are consecutive integer inputs, I could make this output decay by half, by that decay factor. So 1 times half is half. And then 1/2 times half is 1/4. And then half of that is 1/8, and it gets smaller and smaller and smaller. So if going down on the outputs is decaying by half, going in the opposite direction would be multiplying by the reciprocal of 1/2, which is really multiplying by 2. So times 2 is 1/4, times 2 is 1/2, times 2 is 1, times 2 is 2, times 2 is 4, times 2 is 8. We have the coordinates of this exponential decay function. So I want to put that in a cloud because those are not the coordinates that we actually want that belong to this logarithmic function. They belong to this exponential decay function, which we know is the inverse of this logarithmic function. Now, we already know that finding the inverse implies us switching x and y's. So if I actually wanted my x, y coordinates of my logarithmic function, I'd have to switch these coordinates. So I'm just going to switch the -3 and the 8, and I'm going to make it 8, -3. I'm going to switch the -2, 4 to 4, -2, and so on and so on. So I'm switching all my coordinates. And now I'm going to ignore, that's all I needed. These guys, that's all I needed them for, so I could scratch them out if I want. I would just ignore them. And now let's actually plot these x and y values that truly do belong to this logarithmic function inside of the box. Remember, I'm still ignoring h and k. So let's first plot these points on the xy plane and then shift them according to h and k. Man, maybe I should make this worth 3 points. So let's actually graph 8, -3. Wait a minute, 8, -3 is going to be off the graph. So let's go on to 4, -2. So 4 on the x, 1, 2, 3, 4, -2 on the y. And then let's go to the coordinate 2, -1, 2 on the x, -1 on the y. And then 1, 0, 1, 0 is right there. And then 1/2 of the way on the x, up 1. Halfway up 1 is right here. And then 1/4 of the way up 2, which means it's even closer to the y-axis. It's half of the half, half of the half, half of the half. You know, it keeps getting closer infinitely to this vertical asymptote at x equals 0. Okay. However, we still need to shift all of these coordinates according to h and k. So we're going to shift them 3 to the left and 1 down. So every single one of these coordinates are going to go 1, 2, 3 to the left and 1 down, which is right here. 3 to the left and 1 down would be right here. 3 to the left and 1 down. And our asymptote that used to be at x equals 0, if we shift that asymptote 3 to the left, it'll actually be at x equals negative 3. So my asymptote is right here. Let me actually do it in green. Here's my asymptote. That's at the line x equals negative 3. Let me actually graph the rest of these coordinates, getting infinitely closer and closer to that asymptote. I'm actually going to draw it like if it's on it, but I know that it never actually touches, just infinitely approaches. So here's my actual final product graph. And this graph really does accurately represent that log base 1/2 of x plus 3 minus 1. The next question is, state the domain and range of the above graph. Well, if we know that this blue graph going this way, it looks like it's approaching a certain x value and it never gets to the x value of the asymptote. So we know that this entire blue graph is on the right side of x equals negative 3. And that means that it's greater than negative 3, and that's exactly the domain of that logarithmic function. So let's actually go over here and put the domain is x is greater than the negative 3. And the range, well, the range are your y values of this blue graph, and the y values, y goes up and down, and this blue graph really does go up forever. And it really does go down forever. Even though it curves, it continues to go down. So the y values of this blue graph are all the numbers. So y equals all real numbers. Do we understand that? Yes? Okay. It then says, number 5, state the asymptote of that logarithmic function. Well, you don't have to graph it. You see, on an exponential growth or decay function, the k value was your asymptote, right? Like, let's go to, just quickly right here. If I say y equals 2 to the x minus 3, well, we know that's a growth function, and the k value tells us the asymptote. So we would have something like this, 1, 2, 3. So our asymptote would be at negative 3, and it's a growth function, so that would look something like this. Okay? But right here we have a logarithmic function. On a growth function, our exponential growth or decay function, the asymptote comes from the k value. But if you look at this logarithmic function and this asymptote, the asymptote's negative 3. That came from the h value. Okay? So we need to understand that. On a growth or decay function, the asymptote comes from the k value. On a logarithmic function, the asymptote comes from the h value, and you have to think opposite of what you see here. So when I ask you, what's the asymptote of this guy? Well, we already know it's x equals negative 3, but you could just look at this h value and say x equals negative 3, the opposite of what you see here. So on number 5, what would your asymptote of that logarithmic function be? The asymptote is, we're going to say, and we have to say x equals 2, because that'll produce the vertical line crossing the x-axis at 2. So number 5, the asymptote of that is x equals 2. The asymptote for the above graph, I skipped number 3. The asymptote for the above graph was x equals, what was it? Negative 3. So that's like the first part of the test. That's all on graphing. This next part is simplifying. Okay, now these are not equations. It does not say solve. It doesn't say solve. You don't want to get x by itself on one side. It just says simplify. So what does that mean? We need to use what we know, that it's beautiful when you have log base something of that same something. In other words, it'd be nice if this were log base 81 of 81 so I could scratch it out. But it's not log base 81, it's log base 3. So what if I could change this 81 to look like a 3 to a certain power? Could we? Yes, 3 to the 4th power, right? So I could, if I had space here, I could rewrite this as log base 3 of 3 to the 4th power still to the 5x power. So if I have a power to a power, I have to multiply 4 times 5x, that becomes 10x. And the log base 3 of 3, that eliminates, so I really just have 20x left over as my answer. or the simplified expression. I shouldn't say answer, but that's the simplified expression because the log base 3 of 3 cancels. Number 8, what would be nice if I had, what number would I need to have inside these parentheses? A 2, right? I need a 2 in here. So 16 could be rewritten as 2 to the 4th, and if you move it up, it'll actually become 2 to the negative 4th. So rewriting this whole thing, I'd have log base 2 of 2 to the negative 4th power, and it's still to the x power. So yes, power to a power, you multiply negative 4 times x, that's negative 4x, and the log base 2 of 2 eliminate, that's why your answer is just negative 4x. And the funny thing is, with the calculator, with the Casio calculator, not the Texas Instrument, you could actually type this in exactly the way it is, and it'll give you the answer negative 4, and then you just have to multiply it by that x. Or likewise, with the Casio calculator over here, you could actually type this guy in exactly the way it is, and you'll get the answer 4, and then you'd have to multiply it by that 5x to give you your final answer, 20x. Just to let you know. Number 9, what kind of logarithm do I have right here? Is it a log base 3, log base what? 10. Log base 10. So if I have 10 to the power of log base 10, that itself will eliminate right there. So your answer is just 2x. Let's move on to this next section of finding the inverse, right? Finding the inverse. We switch x and y and solve for y. Now, number 10, on the quiz or on the test on Tuesday, you're probably going to be pressed for time, so take any shortcuts possible. Do we have any shortcuts to do on this instead of switching x and y and solving for y? Yep. Y equals 3 to the power x. So the shortcut is to just cover up that log, and it looks like y equals 3 to the power of x. That is your inverse function. Y equals 3 to the power of x. If you would have gone through that whole math process of switching x and y, you'd be able to solve for y and you'd get this answer itself. Do you want to see it or not? No? Okay, fine. Moving on to number 11. Right here, you can't do that trick because there's a h, right? And over here, you can't do that trick because there's a k. So that only works when you don't have a h or k. You could switch your logarithmic form to exponential, or you could find the inverse by simply covering up log. Right here on number 11, let's actually work this out. We're going to switch x and y, and we'll have x equals 3 to the y power minus 2. So we switched x and y. Now we need to solve for y, but y is an exponent. And in order to undo this exponent situation that has a base 3, I have to apply the inverse of an exponent, which is a log. What kind of log am I going to apply to both sides? Log base 3. So left side, log base 3. Right side, log base 3. Well, the log base 3 of 3, this guy right here, will eliminate. The y minus 2 will come down as regular y and 2 values. It's no longer an exponent. And on the left side, we have log base 3 of x. And I do ask, guys, that when you're writing logs, make sure if you're writing the base, you write it small and down here. A lot of people are going to make this look like a common log of 3x. That's going to be incorrect. You have to write that 3 small and towards the bottom. Anyway, we almost have y by itself. All we need to do is add 2x, or add 2, I'm sorry. Add 2 to both sides. So we have this as a final answer, log base 3 of x, and then a plus 2. Y equals, so there's your answer. Y equals log base 3 of x plus 2. No parentheses around the x and the 2 because we added 2 at the very end, okay, which is different from number 12 that we're about to do. Let's move on to number 12. So on this guy, we're going to switch x and y. We're going to have x equals 5 to the y minus 4. And now I need to solve for y. which means get y by itself on the right side of the equal sign. And the easiest thing to get rid of is the minus 4, so do that first. Plus 4 plus 4. You're going to have an x plus 4 equals 5 to the y. So I still need to get this y down from the exponent. How do I get the y down from the exponent? Apply a log base 5, right? Now I am going to do a log base 5 of 5, which will eliminate, but what I do to one side I must do to the other. And notice that on the left side I actually have a binomial x plus 4. That's where I have to put in parentheses and then write log base 5 in front of those parentheses. That way I truly am doing log base 5 of this whole entire left side, not just the x. So anyway, the y comes down and we have y equals log base 5 of x plus 4 in parentheses. Big difference. If you don't put the parentheses, it's going to be wrong. You need to have those in parentheses. So this guy over here, there's no parentheses. This guy over here, there are some parentheses. Very important that you understand the difference. Why are they no parentheses on this one? Because we did the logarithm first and then we added 2 at the very end. So it's the logarithm and then we added 2 at the very end. But over here on number 12, we added 4 first and then we did the logarithm of the binomial x plus 4. That's why you have to have parentheses around that x plus 4.
That plus 4, it's
If we were thinking of the graph of this logarithmic function, that plus 4, you'd get your h from that value. So your h is technically negative 4, right? So your asymptote right there would also be x equals negative 4. Anyway, yeah, y, I would write it on that side. Y equals log base 5 of x plus 4. And the rest of the test is on solving equations and on the back side solving inequalities. And we're going to save that for Monday. Okay?